Okay, so today we're going to be doing LeetCode question 20, valid parentheses. So this question in particular, I would probably argue that it's as well known as the two-sum question, right? This is the number one question when it comes to stacks, right? It's probably the first one that most people do. Um, and stacks are a little bit intimidating. That's a sort of a data structure, right? If you heard of stacks, you may have heard of the other data structure called queues. They're very similar, kind of playing hand in hand, like opposite of one another type situation. But overall, the way we're going to approach this problem is by using the data structure stack, right? So, taking a look at the problem, right? You are given a string containing all sorts of characters, right? And we need to determine if the input of the string is valid or not. So what that means, valid, is that the open brackets must be closed by the same type of bracket, right? So if you kind of have these two brackets here, they need to be the same and close. And the second rule is open brackets must be closed in the correct order, right? So they can't be anything crazy. They need to be like right next to one another or proper. Every closed bracket has a corresponding open bracket of the same type, right? So what this says is, looking at example 2, I think is the most clearest example, is that you're given three types of brackets here, right? And you see how they're right next to one another, they close, and everything is proper within the string. This is a valid parenthesis, and because it's valid, we're going to output true, right? Example 3 is an example of an invalid, where you're given two different brackets, one left, one right, and these do not match up and they're not the same. So we're going to return false. I think example 4 and 5 are some test cases which are really important to take a look at. It kind of gives you an idea of some rules that you need to be thinking about. For example 5, they do have parentheses, yes. So for example, or proper brackets. So like here and here, you see they're proper, but within that, you have a whole other separate side of brackets. And because they're not aligned correctly, right? Because they're not aligned correctly, we output false. So what are we going to do in order to make sure that this is true or false? Like I mentioned before, we're going to use stacks. Now what are stacks, right? Stacks is basically, when you're thinking of this word, think of the definition. First in, last out, right? So what does this mean? So I like to think of everything very literal, right, and very visually. So to kind of demonstrate that, let's say you're placing down blocks, right? You're placing down blocks here, here, and here, right? Well, no, this will be our first block right here. And we want to place more, right? You're going to place it right on top. And then you want to place another one right on top, right? You want to place another one and right on top. And you can kind of see, right, that we've placed 4 blocks, and the top one is our most recent placement, while our bottom one is the first block we placed, right? This is block 1, this is block 2, block 3, block 4, right? Now let's say we wanted to grab the block all the way in the bottom. We can't just go and grab it like that. We need to remove the blocks that we've had on top, right? So if we're trying to grab this block, we would need to remove this block, right? Then remove this block, then remove this block, until we finally get back to the one we originally placed, right? So how are we going to go and do that? Well, I think the question I meant to say is, how are we going to implement that idea with this question? Well, what we're going to do is, first we're going to make a stack, right? So in order to make a stack, you're just going to make a variable and set it equal to these parentheses, right? So these little brackets here represent, okay, we've created a stack, right? We're going to be storing our values in here, but specific values. And the reason why that is, now we're going to do an if statement, right? Well, actually, no, we're going to first do a for loop, right? For characters in S, right? Characters representing each single one of these every iteration. So this for loop is going to run basically X amount of times in S, right? Meaning like, okay, so you have as many things there are in S, and S has 1, 2, 3, 4, 5, 6 things. So character is going to represent each one of those things those 6 times. So the first loop will be the first time, and character will equal to this. The second time, character will equal to this. The third time, character will equal to this. The fourth to this. The fifth to this. The sixth to this. And then we're done, right? So with that being said, right, what we're going to do is for characters in S, we are going to check if S, or if character, um, we're going to check if character is in this, this, or this, right? If so, we're going to do my underscore stack dot append character. So what this is saying is, okay, if we have any left brackets, right, we want to add them into our stack. Else, right? So if you see these, add them to the stack. Else, do what we're going to do right now. We're going to check if character, we're going to check if character equals to, let's say this, right? Then we're going to check if my underscore stack at -1 equals equals this. If it does, then we're going to do my underscore stack dot pop. Else, we're going to return false, right? So what is all this saying? Because we just wrote a whole bunch of code, right? So the first thing we're doing when iterating through S is checking if it's equal to any of these, right? So let's take a look at what's going to happen first, right? Our first loop starts here, right? And here, I'll even write the numbers. 1, 2, 3, 4, 5, 6, right? So we're starting at 1, and 1 is this. If character is in any of these, which is a very simplistic way of saying, okay, if character is equal to this, this, or this, right? Well, yes, our first iteration, character does equal to this right open side bracket. So we're going to add this into my stack. So we're going to update this visually. And now this has this in it, right? Beautiful. Okay. Now we're going to do our second iteration for character in S, this time at index 2, which is this open bracket, but this time to the left side. Is our character equal to any of these? No, it's not, right? It's completely different. So we go to the else statement down here, right? If character equals this bracket, which it does, right? Then we're going to do another if statement. Okay, so it equals to that. That's cool. But is our first iteration in our stack equal to the opposite of it? Well, let's check, right? Yes, it is. You see how it's our first thing that we added, and it is equal to that? So because of that, what we're going to do is do my stack underscore pop. So the dot pop parentheses, this little section here is called the method, right? So a lot of these data structures have methods that allow you to kind of do little shortcuts or do anything. Pop basically just removes whatever, like removes the last iteration. So we're going to remove this because we just popped it from my stack, right? And we're going to continue going. If our stack was not equal to this and anything else, we would have just returned false and just stopped the code right there, right? And if we returned false, that would have been exactly what we've done in example 5, where our output is false, there's nothing that needs to be done, and we're finished with that problem. But in this instance, it is equal to it, so we have to continue going. Now, that's great and all, right, that we were able to check for these types of brackets, but we need to check for the other types of brackets, right? We're not just doing these open parentheses. We also have the square ones and the squiggly ones. We need to make sure that we accommodate for that. So what we're going to do is literally as simple as copy and pasting, because this code is basically universal, right? We're going to elif, right? Sorry, just got to make sure we don't have any indentation errors. And instead of these open brackets, we're going to check, let's do the square ones for now, right? And it's literally as easy as that, right? Then all we got to do is do the squiggly ones now, right? There we go. Squiggly, squiggly. There you go, right? Um, oop, I forgot to do return false. We need to add this little, these little lines right here, and we'll just keep this, actually. Okay. Um, perfect, perfect, perfect. So this is to make sure if we have the left brackets, if the left brackets aren't there, then we're basically doing everything in here, right? And once we're done with all of this, we just want to return the length of my underscore stack equals 0. Okay, so what is happening here? So we're returning the length of my stack. So when it says return the length of my stack equals 0, it's saying, okay, return if our stack, return if our stack's length is equal to 0. So it's going to count how many values are in here and see if it's equal to 0, if they're both equal to 0. And that's the goal. The goal is for both of them to be equal to 0, because think about it. Every time it's right, like every time we see that, okay, well, they both match one another, we're going to pop the stack, meaning we're going to remove the values from here. Just like in that first example I showed you, where we had this open bracket, right? And we removed it, right? So if we continue removing every time everything is working, then by the end of the loop, there should be nothing in. And if there's nothing in, then that means that everything is correct, everything looks good, and we could return true. If there's still stuff left over, then we have to return false, right? Which is actually going to go and I'm going to write this other tiny little section, this test case, right? Test case is just a fancy word for this small section of code which checks for unique outcomes, right? To make sure that everything is accounted for, any type of possibility is accounted for. Because if it's not, and let's say you plug in some crazy input, right, that our code, just like it is right now, does not accommodate for, then nothing can happen. There would be an error, right? And I'm going to actually show you that right now. If I was to click run, let's see. Oh, line 10. It was an indentation error. Let's see. Unexpected indentation. Let's see. Oh, maybe. Oh, because we had that example over there. If character equals this open bracket, invalid syntax. Oh, I see. There you go. Okay. Sorry for that little hiccup. The error was because the else was all the way here. It was wrong indentation. So it was assuming that the else was connected to this if, but it's not. um, the if here and the elif here and the elif here are connected, right? The else is supposed to be connected to the things inside of it. So that was my bad. But overall, back to what you were saying, it's accepted, right? So it looks like it's all right. But if I was to click submit, you're going to see this error. And why is that error? Well, this error does not accommodate for all the test cases, right? So what we're going to do is within this else statement, we're just going to write a simple if statement. If not my underscore stack, right, return false. So what this is doing is, what this is saying is, okay, if not my stack, right? So if there was not, if this wasn't here, right, and if it was just if my stack, what this is saying is, okay, if there's values in my stack, return false. So if you're thinking, if you put a not here, then it's saying if there are no values in my stack, return false, right? And then if I was to click run, okay, so we see that all our test cases are working. And if we click submit, you can see that it does work. Beautiful. So this is what we call a test case, right? So just be really careful to kind of think of the outputs that they're asking you, right? Try to read all the outputs they give you, and then this is common. This is a really common thing because, to be honest with you, I did it initially without this test case, and I was stuck on trying to figure out why it wasn't working. It is important to kind of think of every possible outcome, to read the solution, right, and to add the things that are needed um, in order to get the problem correct and to meet all of its requirements. But overall, just a quick recap: we use stacks, right? Um, we made sure that the value that we were in within the loop was any one of these, which were the open right side brackets. If they were, you're going to add them to the stack, right? And if they weren't, then you're basically checking in the stack, right? So it's like, okay, if not my stack, return false, right? So if there's nothing in the stack, then return false, which is basically, this example is kind of keeping in point that, let's say for instance, our input started off like this, right? There would be nothing in the stack. And we can't start off parentheses like this because this is just incorrect anyway, right? So this is what this is doing. But if not, right, then we're checking if the value we're on, if what value we're on, so whether it be normal bracket, square bracket, or curly bracket, right? And if it is, then we're checking if the first value in our stack is equal to the opposite of it. And if it is, then remove it from the stack. And if it's not, then return false because that's incorrect.